All right, so at this point we're looking at question number 9, and I'm supposed to solve x plus 3 times 2 minus x times x minus 3 is greater than or equal to 0. So notice that this is already factored for me, which is really nice. If you're given a polynomial that's not factored, go ahead and factor it as the first step, but this is already factored for me, which is awesome. So what I did over here is I set each of the 3 factors equal to 0. So x plus 3 equals 0 gives me x equals -3. So that's my first boundary value. So I can draw just a dashed line separator there. Next, I have 2 minus x equals 0. And if I solve that by adding x to both sides, I would get 2 equals x, or x equals 2. So 2 is my next boundary value. Put my separator there. And then x minus 3 equals 0. If I add 3 to both sides, I solve and get x equals 3. So that's my third boundary value. All right, so notice that this creates 1, 2, 3, 4 different intervals that I need to look at. And I'm going to find a test point in each one of those intervals. So let me start over in the far left, and it doesn't matter what I pick. Maybe I'll pick -10 as my test value. And remember that I'm going to plug -10 in for x into all of these factors. And all I care about is the sign result that I'm getting at the end of this. So if I had -10 plus 3 times 2 minus -10 times -10 minus 3. -10 plus 3 would give me a negative result. It's -7, but I just care about the negative. 2 minus -10, negative times negative gives me a positive. So this would give me 2 plus 10, which would be a positive result. And then -10 minus 3 would give me a negative result. Negative times negative would give me an overall positive result, right? 2 negatives multiply to a positive. So the sign in that far left interval is going to be positive. All right, for my second test value, I like to pick 0 when I can. So I see that 0 is in this second interval. So I'll go ahead and use 0 as my test value. I'm going to just erase this and start over. All right, so now plugging in 0 into my factors, 0 plus 3 times 2 minus 0 times 0 minus 3 will give me a positive times a positive times a negative. 2 positives times a negative gives me an overall negative result. All right, in my third interval, it's between 2 and 3. There's not a nice pretty integer that lives between these two. So how about we pick good old 2.5. So that's going to be my test point. All right, so now I'm going to be plugging in 2.5 into my factors here. So 2.5 plus 3 times 2 minus 2.5 times 2.5 minus 3. So 2.5 plus 3 gives me a positive. 2 minus 2.5 would give me a negative. And then 2.5 minus 3 would give me another negative result. A positive times a negative times a negative. 2 negatives multiply to a positive. So I end up with an overall positive result in that interval. And then finally, let's choose black. So it doesn't matter which number I pick. How about a 7 for my test point? So I'll go ahead and erase and plug 7 into all my factors. So this would give me 7 plus 3 times 2 minus 7 times 7 minus 3. So this is positive times negative times positive. And these would multiply out to a negative value. All right, so I've filled in my intervals. I've got positive, negative, positive, negative. I think I mentioned in the previous video that that's a really common pattern. So usually when I see plus, minus, or minus, plus, minus, plus, that gives me a little bit more confidence. It is certainly possible to see, 2 positive intervals next to each other, but just double check that if you see that, because it's uncommon. It certainly can happen, but it's more common to see that alternating pattern. Okay, so going back to the original question, I want those factors to multiply to something that is greater than or equal to 0. Values that are greater than or equal to 0 are either positive or 0. So I'm looking for positive portions of my interval, right? So my final answer is only going to display the positive intervals. And note that I'm going to be using square brackets. So I'm going to be using square brackets because it's greater than or equal to. So I'm going to have this portion of my interval, right, where my solutions are positive. And I'm going to have this guy. Oops, sorry, that's really bad. But this guy with the positive also. All right, so on the left, I have the interval going from negative infinity up to my boundary value of -3 using a square bracket, union symbol, and then I have the interval between 2 and 3. Okay, and by the way, if I were to graph this solution, because you'll be asked to do that on occasion, so here's -3, -2, -1, 0, 1, 2, 3, so on and so forth. So if I were asked to graph my solution, I would have a square bracket at -3, draw my arrow to the left, and then I'd have a square bracket at 2 and 3, and I would just connect those two together as well. So that would be my graph solution. Okay, let's take a look at number 10. So for number 10, again, it's already factored, which is really nice. I have 5 minus x times x plus 1 is less than or equal to 0. So setting each of these factors equal to 0, if I set 5 minus x equal to 0, that gives me x equals 5, because again, I could add x to both sides, get x equals 5. So that's my first boundary value. And setting x plus 1 equal to 0 gives me x equals -1. So that's my other boundary value. Okay, so plugging in my test values, doesn't matter what I pick, but let's say I pick -10 for my first. So 5 minus -10, and then times -10 plus 1. This is going to be 5 plus 10 times -10 plus 1. So this gives me a positive times a negative, which overall gives me a negative result. So I have negative values on the far left interval over there. And then in the middle, I like to pick 0 whenever I can. So let's plug in 0. This would give me 5 minus 0 times 0 plus 1. This gives me a positive times a positive, which equals a positive. So all values in that interval, when I plug values from that interval into the polynomial, it would give me a positive result. And then finally over here to the right, doesn't matter what I pick, so maybe choose positive 10. And let me just erase this so I have a little room to write my work. All right, so I've got 5 minus 10 times 10 plus 1. So this gives me a negative times a positive, which would be negative overall. All right, so I want 5 minus x times x plus 1 to be less than or equal to 0. Values that are less than or equal to 0 are negative. And for less than or equal to 0, because there's that equal to bar, I'm going to be using square brackets here. So I'm going to be picking out the negative intervals. So the interval to the far left has negative values. When I plug the values in, it gives me a negative value of the polynomial. And the interval to the far right also produces negative values. So I'm going to write this as negative infinity up to my boundary value of -1, square bracket, union, my boundary value of +5 with a square bracket, up to infinity. Okay. And as a reminder, if you're watching these in number order, so when we get to number 11, just to kind of compare these now that they're both completed, when we get to number 11, which I've already worked on, notice that number 11 has the same components. It has the same factors in it. It has 5 minus x, and it also has x plus 1, x plus 1. So it has the same factors. You end up with the same boundary values of -1 and +5. We're still setting it less than or equal to 0. And notice that the difference between these two solutions, is for my polynomial inequality, I have a square bracket here at -1. With my rational inequality, I have a rounded parenthesis here at -1. The difference between the two is, with a rational inequality, there's that extra restriction that your denominator can't equal 0, so x can't equal -1. So I'm not allowed to put a square bracket for my rational inequality solution at -1. So if you haven't watched the video for number 11 yet, check that out and then come back to this, and then this compares the two results. So polynomial inequality versus rational inequality, that's the only difference. There's that extra restriction when you have a variable in the denominator, well, which you do with rational inequalities.